Hello, everyone, and welcome to the web breakout sessions. My name is Ada Nduka Oyum, and I am hosting today's breakout room all the way from Lagos, Nigeria, with my co-host Zviad all the way from Russia. Hi, Zviad.
Hello, Ada. Great to see you. Thank you very much for joining us today. My name is Viad, and I'm joining you from Moscow, Russia. We'll be your hosts and co-hosts.
Thank you. So this web breakout rooms are going to be having three different sessions. One on boosting performance for your data-intensive apps with Micro-Frontends with Natalia. And next, we're going to be having native web apps with Daya. We're going to talk about native web apps. And then lastly, we're going to be talking about Fitbit development, SDK, and how you can build rich apps focused on health, data, and well-being. So now I'm going to bring up to stage Natalia, then Dito. Hello, Natalia. How you doing?
Hey, how are you? I'm very glad to be here.
I'm fine, thank you. So, for those of you who don't know, Natalia, after leading teams as a technical lead and software architect for some of the largest web platforms for leading brands worldwide, Natalia works in the role of a senior solutions architect with MongoDB. She is also a GDE for Angular and web technologies and also a Microsoft MVP for developer technologies, and is going to be taking the stage right now. So, Natalia, all over to you.
Thank you very much. And after this introduction, I think there is not a lot left to say from me, but I'm super glad to be here. Thank you for having me. Like Ada mentioned, I've been working in the industry for over 15 years. I've been in the role of developer, front-end developer, technical lead, software architect. Right now, I work with MongoDB as a senior solutions architect, like she very well said. And I am also very involved with the open source communities and do a lot of public speaking and knowledge sharing as an Angular and web technologies GD, also as a developer technologies MVP. But I'm very thrilled to be here to talk about databases and performance and how we can architect our applications with these two in mind. And we're incredibly lucky today because we are living in the era of cloud native development. And cloud development unlocks a vast amount of features and technologies we can use to simplify our architecture, decouple systems, minimize third-party dependencies, reduce the total cost of ownership, and in the process, enhance both developer and final user experience, which is always very, very tightly coupled to performance. So let's talk about a simpler architecture because in the end, that's the beginning of it all. The slimmer the design of a system, the least components it has, the easier it is to optimize its performance. And the folks making architecture decisions are responsible for deciding on and defining a base foundation for a system that meets performance expectations. If they err on the side of complexity, well, it will always scale that way. How can they make sure to build on top of simplicity? They need to start by understanding what's available to them in terms of technology and formulate the right questions so they can use architecture building blocks more effectively. And what are those building blocks, those pillars? We've heard about this for a very long time, but how much do we pay attention to it? People, technology, and processes. When it comes to a system, they mean nothing on their own. They only have a meaning when they are properly interconnected and answer questions, when they provide solutions. So the simpler the process, the more focused each technology is at solving a unique problem, the more it will enable people. We hear sometimes the cloud is super complex because it provides way too many services, but we don't need to use them all. We don't need to know all of them, and we don't know how to implement each one of them. We don't need to know the nitty-gritty details of the mechanisms they enable, and we definitely don't have to worry about provisioning the right infrastructure or working in its maintenance. The cloud allows us to break down monolithic complexity not only into multiple services, but also delegate a great deal of responsibility to service providers. so we can move faster, iterate quickly, and deliver in time as developers. This is the ideal setup for microarchitectures. Basically, we all know this is more or less an accurate representation of the layers of a monolithic application. When we think of monoliths, we think about those very large enterprise apps with a bunch of stakeholders behind it and more than one cross-functional team working on it. Thousands and thousands of lines of code in the code base and a massive infrastructure. It makes me tired to think about it or to describe it even. When we have a very large cross-functional team dealing with a monolith, sometimes people have to learn to they have to catch up with a new technology or pattern in order to be a productive member of this very large team. Usually there is a lot of imposition, right? When others make decisions that most of the team doesn't understand, and there are less chances for members of the team to contribute with ideas, to have, they have to accept definitions that are made at a larger scale without really understanding the whole system or having access to a broader overview of it. This kind of configuration leads to knowledge silos. There is usually a layer of the team that works more or less in the darkness, not fully understanding the dependency graph for their project, having to focus on the problem at hand. It is very difficult for them to understand the whole scope since they don't have access to all those areas of knowledge, nor the time to contribute to them, right? So, however, inevitably, every change they make, be it very tiny as it may be, could lead to a dependency disaster. We know that feeling, right? You open a pull request and then you get a million commands coming from all directions that can potentially break XYZ, and you have never even heard about XYZ before. That results in very stressed team members, in very stressed team leads that have to deal with a lot of low-level knowledge and safeguarding all areas of the application, from core libraries to components, having to make sure that integrations don't break dependencies, that patterns are followed at a very large scale, and that versions are supported, that the whole thing is documented at scale, having to block and sometimes discuss against very intelligent ideas on how to improve, because there is never the right time to start implementing changes, and there is never budget to cover for it, especially when it's a system already in production that is very data intensive, that has a very low performance budget, and that is actively iterated and keeps scaling over and over. So in the end, we end up with a very high technical debt, high TCO or total cost of ownership, unsatisfied teams, the lack of a sense of effective contribution, autonomy, and independence to make any kind of technical decisions, innovate, or use newly acquired skills. What many teams and even business stakeholders don't come to realize is that these kind of scenarios not only damage the team and the business, but also the final user. The road to innovation is blocked, and it feels like there will be no way out. And at the same time, competitors or people that are developing other applications may have chosen a different road. And when we can no longer compete with their progress, our performance is immediately impacted in a negative way. And that may be the state of things until everyone agrees that executive and technical decisions that we make at an architectural level should have two goals: bring business value, obviously, and enable a great experience for the final user and for the developers as well, particularly now when applications become more and more data intensive. They gather more data than ever by different means: sensors, smart devices connected to the internet, and of course, interaction with the users who are more and more demanding when it comes to performance. They not only want accurate real-time information, they want it now. The patient thresholds are really low, and it's increasingly more difficult to satisfy perceived performance expectations, particularly for handheld devices. I remember when I started developing front-end applications, and it was the share market for mobile devices, it was below 15%. Right now, it has reached nearly a 54% this very November, surpassing the desktop traffic by a good 10%. As you can see in this graph, it continues to grow at an accelerated rhythm. Mobile devices are always with the users. They perceive them as an extension of themselves, and the expectation of speed in rendering data is much higher than it is for desktop devices. So abandonment rates are much higher at a shorter time when the user is accessing data from mobile devices. And Google has great public information to describe these benchmarks. Application owners, developers, and businesses cannot afford degraded performance. It's simply not affordable to have a bounce probability of 32% when a request for data takes longer than 1 second. Especially when we continue to move forward in the direction of huge amounts of data collection to an estimate of 175 zettabytes in 2025. So what measures have we taken so far as an industry to simplify architectures, reduce total cost of ownership, and enable individuals and teams? Well, for once, microservices and its equivalent in the front end, or Micro-Frontends, when we as an industry finally realized that instead of having a very large monolith taking care of all the data requests and operations, we could separate concerns and build specific micro applications or services to serve a specific purpose, right? This type of architecture is very effective in solving problems, or the problems we have discussed, simplifying architecture in smaller decoupled blocks, reducing dependencies for larger scope, removing silos, granting teams with independent architectural and tech stack autonomy, and independent deployability. But there is a trade-off, right? The solution requires specific team configurations and dedicated processes, because in order to successfully implement this breakdown, the idea is to map each unit to a business capability or logical domain. These logical domains must comply, or they should abide by certain rules to be successful. There should be only one business domain associated to each unit. There should be an independent team owning the feature and making their own architecture and processes choices. There should be no shared logic, and each one of these small parts should be able to fail silently. But should each one of these independent parts own its own data and database? We will answer this in a little bit. As you may have noticed, until now I have referred to our applications as microservices plus micro-frontends, and you're probably wondering, wasn't this talk about micro-frontends? I am a front-end developer. I know nothing about implementing a backend, nor do I want to know. And what is she talking about, right? So you're lucky, because we spoke about the cloud before, and you don't need to be a backend developer to write and ship applications end-to-end when you're working on the cloud. Any team or developer can leverage the options given by these infrastructures to reduce the total cost of ownership by adopting serverless computing and triggers to run operations that may not require to write extensive business logic as a full-fledged backend, right? But simple executable functions that run independently, or to generate publicly exposed or private API endpoints without having to resort to complex implementations and the necessary infrastructure to run them. This strategy allows us to further decouple our applications while we keep the complexity of the overall code base in check. We reduce the maintenance efforts, we deliver more quickly, and we benefit from existing infrastructure, like I said, that we are not even responsible for, which is the best part. It also enables front-end developers to use their current skills and experience with languages like JavaScript or API query languages like GraphQL to write services end-to-end against most modern databases. And you're still wondering, but what about the data itself? So in the previous diagrams, we saw a representation of several typically containerized microapplications. We discussed how we could leverage cloud serverless functions, triggers, and other types of hooks to reduce the total cost of ownership and speed up delivery. But again, what do we do with the data? Should we always containerize data together with our microapplication, or should we share it between components or microapplications with an API-first approach? So the answer to this will very much depend on the data type and model you're dealing with, and if the data sets are shared or not between components. It will also depend on the backup and recovery mechanisms available to your database of choice, but categorizing databases is not as simple as it may seem. We can use different types of categorization. The most straightforward is by how data is queried. It can be queried using the popular and very well-known structured query language, or SQL or SQL as you want to call it, or with a different language, which makes it obviously no SQL. But there is a lot more. Regardless of the query language, databases admit a diversity of models. Back in the day, there was a prevalent model, the relational one, and relational database management systems were nearly the only option to build websites and applications. When you were working on top of this unique option and you had a monolithic architecture, it made sense that you only had one database. But at some point, we started organizing our monoliths in modules, and the more modular the monolith was, the more tables you probably had, the more relationships, the more complex the queries, the more latency, the least performance. Now we have multiple models to choose from. We have document stores, we have key value, we have graph, we have time series, search engine, wide column, spatial. We have tons of models and databases to support them. It's probably easier for you to connect the dots when you see technology names that are very popular with us, the developers. And as you can see, there are plenty options you can choose from. And what database you may select to store the data for your micro application architecture may have a lot to do with the use case or the solution you are providing, right? Now, you have a micro applications architecture, you can use a dedicated database for each one of those parts when it makes sense, obviously. And choosing the right database, depending on the type of data, is already the first right step to accomplishing great performance. This matrix is a guideline on how you can better decide for one, and you can see there are many different use cases associated. We are no longer restricted by complex relational systems that require object relational mappers in the middle to map objects in our code to the data in the database. This type of NoSQL databases typically don't need you to put the application offline to extend or change the model because they are usually cloud native. They implement replication mechanisms that give you a lot of flexibility, not only to change the model, but also to perform all types of maintenance tasks like version upgrades and patching and so on. Take the example of a search engine database. They are also implementing specific indexing algorithms to optimize data retrieval, like inverted indexes in the case of full text search, and that already contributes to a more performant model. They are also prepared to handle immense volumes of data, like wide columns, or to operate with very, very complex object types, like coordinates. And there are even those that will allow you to store multiple values or types of values that come equipped with integrated mechanisms to aggregate, operate with, or transform data. So if your micro application is dealing with data and a use case that no other service is dealing with in the integrated system, once you have orchestrated everything and works with it in isolation, then the answer is probably yes, you definitely can containerize the database together with the rest of your implementation. But there are more options. Most cloud databases will allow you to create different logical databases in the scope of a same deployment. So how you answer this question will depend on how independent are the teams working in the many different micro applications, how feasible it is to have a centralized user management, typically API keys or certificate, plus role-based access control to authenticate and authorize users and services, and whether or not you need to aggregate data stored in the different databases. If the answer is yes to all of this, you can definitely resort to logical partitions instead of independent deployments and keep all data centralized in one layer, which makes it more manageable. There is even another approach. When more than one application is using the same data set, you could resort to data duplication. Now, data duplication may seem like a bad practice, but for cloud databases, it is not, particularly when there are systems in place to guarantee replication and synchronization in an automated way. However, there may be cases where data is shared between several microservices, and particularly when data is of a type that needs to or tends to generate great volumes of data over a very short span of time, and consumption should be in real time, and synchronization may suppose a great effort. Instead of duplicating, you may want to implement an API-first approach that could help in having one single data storage layer that will serve different services with or without sharing additional infrastructure. So we can already come to the conclusion that making sure your data-intensive applications are performant and defining what good performance actually is takes a lot more thought than maybe you have imagined before. And that when you're running data-intensive applications, especially if they're mission critical, performance spans end-to-end, presenting common problems with common solutions to all databases and unique problems that cloud deployments will help you solve. So no matter what database we're talking about and of which type, one thing that will contribute to better performance for sure is to have optimal data modeling and modeling patterns. Usually one should store data in ways that optimize its access, be it for reads or for writes. One important advantage of document databases when it comes to performance is that data queried together can be stored together in a single document, for example. So you access the data from a single point and everything is there. That definitely contributes to the overall great performance of this type of databases. When it comes to microarchitectures, another benefit of using a document model or NoSQL database is that schemas or ORMs are not necessary. That allows for faster iteration and greater developer productivity. However, schema validation, if necessary, can be enforced either for the whole data set or parts of it, which makes it even more ideal for this type of architecture. Indexing strategies are essential also for the optimal performance of all databases. An index is a way to quickly locate and retrieve data in a database by copying the data structure, usually in memory for fast and direct access, with a key or link to the data we will be querying. Indexes can be filtered, or they can be sparse, they can be unique, they can be compound, which means they consist of many different keys, and they make possible covered queries, meaning querying data for which we have an index and will be faster to retrieve. Workload isolation is a great way also to improve database performance that can be specially taken advantage of by microapplications architecture, particularly in the cloud. Now, this is an advanced feature, and yeah.
Hi, Natalia. Sorry to cut you in, but we are a little bit way over time, and your session is pretty exciting. But just so we can keep to the schedule, would like you to kind of like summarize so that we can move ahead.
Okay, I thought I had 30
audience as well.
I thought I had 30 minutes, but yes, sure. Okay, just let me wrap up quickly. So with workload isolation strategy, we can target read-only nodes from specific micro-frontend components. And you can see over here that when you have different kind of operational workloads, you can query from different nodes and make it all easier. You can also resort to global distribution when you are in the cloud. You can work from the edge of the network. That is the ultimate strategy, implementing edge databases to not only store but also transform processes of or process data or at or near the collection point. That is very, very powerful. So these databases often come equipped with conflict resolution, synchronization, and an optimized small footprint, which makes them ideal for micro-frontend architectures. And I don't want to take any more of the next speaker's time, but now with performance in mind, we have already made impactful decisions for both our architecture, including our databases, and adopting micro-application patterns, thinking about people, processes, and not exclusively technology. We are giving teams the chance to really own the tech stack and their implementation in line with their particular skills and experience, including the databases. So thank you very much. This is all, and I hope you have enjoyed. I hope you have a better idea on how to optimize your micro-frontend architectures. And yes, and also keep in mind that you can decide for a database that maps to your micro-frontend and fixes or solves a unique problem. Thank you.
Thank you so much, Natalia.
You're welcome.
Once again, I'm sorry for cutting you in, but your session was really, really insightful. I'm definitely going to be practicing a few of the tips that you have shared right after the session. But thank you once again. And thank you to everyone who has been staying tuned to the to Natalia's session. We'll be having the next session in a few minutes with Maxine all the way from Oslo, and he's going to be talking to us about something pretty exciting.
Okay, thank you.
Hi, Svea, are you ready for this?
Yes. Thank you, Natalia, for your talk. It's been a very interesting talk.
Thank you so much.
And looking forward to dig a bit deeper into micro-frontends myself, to be honest.
Okay.
True.
Have
all right,
fun.
Thanks, Natalia. And
Bye-bye.
See you
Thank
all
you.
in a few minutes.
See you.